Last lesson we proved that polygons are congruent. In order to prove polygons are congruent, you had to prove all angles and all sides are congruent. But if we know that all three sides are congruent, so if I had this side was congruent to this side, and this side was congruent to this side, and this side was congruent to this side, it would follow that all of these angles are also congruent too. So this angle is congruent to this angle is congruent to this angle. So if we know that three sides of one triangle are congruent to three sides of another, that's called side, side, side. The other one is if we know that two sides are congruent. So if I draw two sides like this, and the angle in between the two sides are congruent, then the only way I could draw the third side would be congruent too. So if you try it, there's no way that you're going to have anything different than the third side. So then all three of these angles are congruent too. So that's called the side angle side postulate. So as soon as we know that three sides of one triangle are congruent to three sides of another, we can say the triangles are congruent. As soon as we know that the sides and the angle in between them are congruent, then we can say the triangles are congruent. So just like any proof, I'm going to write out the given. Okay, so I wrote the given, so I need to write given, and then I'm going to go over and mark it. I also drew in this line right here because I think that just didn't copy well. So if I put M as the midpoint of XY, remember if we know something is the midpoint, we can assume that the segment XM is congruent to the segment MY by definition of midpoint. So I'm going to mark this is equal to this. I did that in blue. Now I'm going to mark the second one. XY is congruent to the segment AY. So XY, or AX, is congruent to the segment AY. 2 ticks, 2 ticks. And that's also by given. So I've used up all my givens, and I only have two sides. I don't have anything about angles. So the last thing I'm going to check for is if the triangles share a side, which they're sharing this side right here, that side is congruent to that side. So I'm going to write AM is congruent to AM. And remember, if it's the same thing on the left-hand side, it's the reflexive property of congruence. You can just write reflexive if you want. So now I'm going to mark those 1, 2, 3. So I have three sides that are equal to three sides of another triangle. So now I can prove that these triangles are congruent. So triangle AMX is congruent to triangle AMY by side, side, side. Okay, so this is not a proof, but I'm just going to kind of walk through it. Given that AD is congruent to BC, which we have already marked, what other information do you need to prove that these two triangles are congruent? So it looks like I just have two sides that are in common right here. But remember, I need to either have side, 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 or side, angle, side, where the angle is between the two sides. So I can already mark right here that I have DC is congruent to DC by reflexive property. So I have two sides congruent. So I need to know that these red segments are congruent. So that would be one thing I would need to know. I would either need to know that the segment AC is congruent to the segment BD. That would give me side, side, side. But we also need to know an angle to get side, angle, side. So I could have that these two angles are congruent. These are the two angles that are in between the two sides. So I would also, if I did side, 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 I would need to know AC is congruent to BD. But to do side, angle, side, I would need to know that angle ADC is congruent to angle BCD. Okay, and the second one, we're going to mark these. These need to be segment lines. Given that these two angles are congruent, so I'm going to go over and mark them. RSG and RSH. And that SG, the segment, is congruent to SH, the segment. Can you prove that the two triangles are congruent? Explain. Well, if I want to do side, 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 I would need to know that these two sides are congruent. And I don't have that information. But I do know that these two sides are congruent by reflexives. So I do know that RS is congruent to RS by reflexive. So if I know that, then I can say that by side, angle, side, they are congruent. So see how the angle is between the two sides. That's why it's side, angle, side. So we can, yes we can. Yes, we can prove by side, angle, side. Because I have it in my diagram. Side, this side, and this side, the angle in between the red side. Okay, in triangle VGB, so I'm going to write that VGB, which sides include angle B? So if you draw the angle B, the red sides are the side that include it. So side BV and BG. Okay, in this triangle, triangle STN, it says which angle is included between the sides. So if you color in NS and you color in TN, the angle that's between them makes up the sides. So the answer is angle N. And the last one, which triangles can you prove congruent? Tell whether you'd use side, side, side or side, angle, side. Right now I don't see a side, side, side. I would have to know that this and this they were equal in order to be side, side, side. But I can say that these two angles are congruent, so I can write that angle APB is congruent to angle YPX by the vertical angle theorem. So then, since this angle is between these two sides, then I can say that the two triangles are congruent by side, angle, side. Okay, if I were to use, say these two triangles were congruent by side, 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 I know that DW is congruent to DW because of reflexive, but I don't have that these two sides are equal. So I can't do side, side, side. If I do side, angle, side, I would have to know that these two angles are congruent. Later on that we can tell that they're supplementary and they make, so it looks by the drawing they are congruent, they're right angles, but we can't assume anything. So, and the last one, can you prove that triangle SED is congruent to BUT? So I don't have side, 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 so I can't do that. And I do see that I have a side and an angle and a side, but the angle is not in between the two sides. See how the angle is not in between the two sides? If it was in between, it'd have to be right here, and it's not. So we can't. So there's nothing that can be proven.